logarithmic function. Okay, if y, which is f of x, is equals to log x to base a, which is a logarithmic function, I want to look for the y dx. So we can use our first principle to derive the differentiation. Okay, and the formula for our differentiation from the first principle is f prime of x is equals to limit as delta s tends to 0, f of x plus delta x minus f of x all over delta x. We know this particular formula, right? Okay, so when we introduce this here, this is going to be a limit as delta s tends to 0 log x plus delta x minus log x all over delta x. We know this law of logarithm that says log a minus log b is going to be log a all over b. That is, you take one of the logs, then a over b. This the subjects will be divided, right? So you apply the same principle here. It's going to be lim as delta x tends to 0, 1 all over delta x log x plus delta x all over delta x all over x, right? That is, this one is the numerator and this is the denominator, right? So if this cuts this and this divided by this, we have the lim as delta s tends to 0, 1 all over delta x log 1 plus delta x all over x. Okay? Okay, so this one now, we can simply rewrite this one as lim as delta s tends to 0, 1 all over x, and x all over delta x log 1 plus delta x all over x. So why are we introducing this? We're introducing this because we want to find a limit of this particular expression. And that expression is that the limit as n tends to infinity of 1 plus 1 all over n raised to power n is going to be equal to e. And e is a special number in mathematics. That number can be found in our calculator 2.71828. Approximation, right? If you have a calculator here, you can easily find that particular. So if you look at our calculator, if you press on and you press this E, this is E, then click on this, you're going to see it's there. So it's just like pi. Like pi is our 3.142. You can see they're in the same place. Pi, the same place where pi is. So it's a special number in mathematics. And then when you find this, you know that when you have an expression like this, you are going to get this particular value for it. So we want to express this one to be in that particular form. So we know that there is a particular law in logarithm that says log a log b to base c. This is going to be log b raised to power a to base c. That is, this a is going to be raised to this power, right? So we can as well take this one to this place as power, and that's going to be lim as the s tends to 0, 1 all over x log. We should not forget this for the fact that this one is to base a. Okay, to base a to base a. So this is going to be 1 plus delta x all over x. Then this is raised over x all over delta x. Okay, you see that this is the inverse of this, right? So which means we can rewrite this one as limits at delta x tends to 0, 1 over x log 1 plus 1 all over x over delta x, x over delta x, right? So if we say let it be equal to x over delta x, we can rewrite this one as, let's put it here, limits as ds tends to 0, 1 all over x log 1 plus 1 over n raised to power n, right? Okay, now this one as it is now, as ds tends to 0, as delta s tends to 0, n tends to infinity, right? So we can rewrite this one like this. We can shift these limits into these particular subjects. Okay? It's going to be 1 over x log to base a of lim n tends to infinity 1 plus 1 all over n raised to power n. Okay? So the entire expression here is now equal to e, right? So this is now going to be 1 all over x log e to base a. So this is the final expression. But this can still be it can be simplified further in the sense that we can apply this law of logarithm that says log a to base b. It can be rewritten as log a to base c all over log b to base c. That is, we can introduce a new base, a new base to the two subjects. That is the one at the top of the denominator. Okay, so we can do the same thing. We want to have this one to look like 1 over x log e to base e, then this one is log a to base e. Log e to base e is 1, right? And then this is going to be equal to 1 over x 1 all over log a to base e. So another way of writing this is ln a. Okay, so this is now equal to 1 all over x ln a. Okay, so which means if our f of x is x to base a, then the derivative is going to be 1 all over x ln a, right? So this is the final expression. Okay, so that's it. Thank you.